Yeah, then welcome to the talk. And thanks for the introduction, Markus. He already said a lot, so I keep this short. So my name is Johannes. I studied IT security here. I did my PhD here. I co-founded the HackPra in 2009, as we just heard. And I was a co-founder of the Flux Fingers. Many Flux Fingers faces here, I see, which is always great. And then I worked as a security consultant. And in that time, working as a security consultant, playing Flux Fingers, I developed a tool for automatically detecting security bugs in PHP code called RIPS. And that's basically the foundation for our company that we founded in 2016. So we have a startup company here at the campus of Ruhr-University Bochum, where we develop our static code analysis tool, RIPS. Yeah, what I love since many years is hunting security bugs. I mean, that's what I did since 10 years now, and that's what I'm going to talk about today. Security bugs and PHP applications. Why PHP? I think it's obvious PHP has just so much attack vectors. It's so much more fun than other languages. That's the initial idea. And we see here some bugs we reported this year in many popular open source applications, like PHP BB3, WooCommerce, the largest e-commerce plugin for WordPress, WordPress itself. We see Moodle, the e-learning platform that runs on the Ruhr-University Bochum as well. Many other shop software, Joomla is part of it. And the main goal as an attacker is always to get like the command execution, right? The remote command execution, the RCE. And that's, I think, what was topic of the past lesson in the HackPra. And today we're going to have a look at some of those RCEs, how they look like in real-world applications, in those open source applications. And well, most of the times I think there are still RCEs available. You just have to look for them, and you just have to find some neat tricks and some tricks to combine maybe certain vulnerability types to get RCE in the end. So that's what we're going to talk about today, just some fun and some security bugs, nothing too much educational maybe, but let's see. We are going to focus on those ones listed here, so PHP v3, WooCommerce, WordPress, Moodle, and Shopware. So let me begin with a very easy example. So that was a traditional code injection flaw in Moodle, and that's something you saw in the past HackPra session, I assume. Very easy code, but the bug was detected, I think, like 3 months ago in Moodle. So it's pretty recent, actually. And this is just a starter, right? So what we can see here is the plain eval statement that you would find in code, and you as a security guy, you would say, oh, wow, that's interesting. I have to look up what's going on here, right? So can I somehow influence this formula? And what happened in Moodle is that if you are a teacher, and depending on your Moodle configuration, you can create a new course, like a teaching course, and you are your own teacher and your own teaching course. Then you can create questionnaires for your students. And you can say, okay, my question to the students should be answered, but the answer for all students shouldn't be always the same. It should be something variable, right? Something dynamic. So the students, as lazy as they are, they cannot share their answers. So what happened here is that Moodle decided that you can specify a formula as an answer, and this formula is produced in this code. I'm not going to into the details of all of those substitute variables and find formula errors. What basically happened is that you as an attacker, you first may want to inject a simple exec and then your get parameter, right, in PHP, which would mean right, if you can inject as a formula here the PHP code exec and then a get parameter, you could execute arbitrary commands by receiving them from the address bar, right? Now the problem was with Moodle is, and I hope you can read that, if we would inject something similar like exec and then the get parameter in PHP, you can just use backtick characters, which is the equal to shell exec in PHP, which executes PHP code. Then this would be an illegal formula, because the formula would try to find out, is it a valid formula? And the idea of the formula is to substitute parentheses, curly braces, with specific numbers. That's the idea of this formula, so you can have variable definitions. So what we did is in the end to find a formula that is a valid formula first, and second of all still leads still has some PHP code inside. So injecting a typical shell exec get parameter would be an invalid formula, but injecting curly braces around that would be, for now, a valid formula, but it would replace things in our formula, so our PHP code wouldn't be executed anymore. And then the next step is to just trick the formula by substituting more and more curly braces in those curly braces. So in the end, it would replace some part of our formula, but leave the initial PHP code injection here valid. And then the last part would be to find out a way that our PHP code is still syntactically valid, so it's still executed, right? As I said, nothing too interesting happening and going all. It was a regular expression doing those things. Too complex to explain in the slides, but in the end, actually a very easy traditional command or code injection that can be turned into a command execution, right? Okay, once injected as a formula, you could then access your questionnaire, append a parameter to the address bar, right, and say, okay, I'm injecting this system command. Please put the etc passwd file into the web directory, into the hire.txt, and then you could read out the etc passwd file as a proof of concept that you executed PHP code. Okay, that was just like a easy example, right? It's the traditional, like, year 2000 code injection. Nothing that you will find too often nowadays, right? Nobody uses really eval or exec, you might say. So let's see at some different examples how we could gain command execution in WordPress. WordPress being the most popular web application on the internet today with 33% market share. And what happened here is we could leverage a file delete vulnerability. The code itself is very easy. It's basically some user input being passed by WordPress, and that is put into an unlink function of PHP, which deletes files, right? But I'm going to show you just a video because it's a bit more visual what we do here. So we need an auto rule. We need to have some kind of authentication. I'm going to comment on that later. So we assume for now we can log in and we can upload a picture as an author. The author is very limited in the privileges. We cannot install WordPress plugins, then we would have a command execution right away. But at least we can upload, we can write posts, and we can upload pictures. And what we do now here, you don't have to read that actually. What we do here is in the DOM and the HTML DOM, we modify that the picture that we just uploaded, which we are going to delete now in a second, that the file is actually not the ripstack logo that we uploaded, but we will modify it to wp-config.php file. Meaning once we modify that in the DOM and we hit the delete button, we don't delete our picture, we delete the WordPress config file. And once we delete the WordPress config file, WordPress thinks, oh, I'm not installed anymore. Someone needs to install me. Here's the installer, right? So you go to the domain of that attacked instance and you get the nice installer where you can change now the database credentials. And you as an attacker, you don't know the database credentials to the server you were attacking, but you can put the database credentials of your own server, right? So ripstack.com or attacker.com is my domain, and I point the database credentials to my own database server, which now means that this WordPress instance fetches all the data from my WordPress database. And since I'm controlling the complete WordPress database, that means I can again get a command execution because WordPress is operating on this data in the database, and I can use reflection and execute arbitrary PHP code there. So that was a nice little trick. Okay, now you say, well, I need an auto rule. That's boring. Well, there are some use cases for that as well. First of all, if you run a multi-user site, that means you probably have a couple of journalists. So WordPress is run by Bloomberg. WordPress is run on whitehouse.gov. Not sure if Trump writes all his articles himself. He certainly also has some journalists. And those would be probably a more easy target to attack there and then escalate your privileges. And apart from that, we also have some WordPress 0 days that are currently fixed by Automatic, the company behind WordPress. And those bugs allow to actually have some unauthenticated access and to leverage your privileges to an author role or to an administrator role. So in combination, that bugs becomes even more critical at a later stage when we will release the details of upfollowing bugs. Okay, just because we looked at this file delete bug, we look also at another file delete bug. It's a file delete bug in WooCommerce. And the technique itself, I mean, it's nothing too sophisticated, right, deleting files, but it just gives some ideas what you can actually do with not only injecting own code, but actually removing code, right, which then leads to a different behavior of the application itself. And that's the same idea here. So to look at the bugs, at the bug from WooCommerce, we have to first understand the design principle in WooCommerce or in WordPress itself. So what happens is if you install WooCommerce, so WooCommerce is an e-commerce plugin for WordPress to set up your own shop system, right? So your own e-commerce shop. And what happens if you install WooCommerce, then you install automatically a shop manager, and this shop manager gets the edit users privilege. That is because the shop manager, he can edit products in the WooCommerce shop, but he can also edit other users of the WooCommerce shop, right? And this access privilege or this edit privilege is stored permanently in the database, right? So it's kept there persistently. And now this would actually mean that the edit users privilege, once you get that, this WordPress privilege, this would mean the shop manager could edit the WordPress administrator. And that would mean the shop manager could edit the password of the WordPress administrator and take over the WordPress instance. And that's nothing that should be happening. So to restrict this, WooCommerce adds a filter, and that's doing exactly what the name is. It disallows to edit admins, right? So there is an admin filter. There's like a hook. Whenever the WooCommerce shop manager wants to edit users, he's allowed to edit users, but it's first check, hey, are you trying to edit an administrator here? And if so, then I deny it. And the design flaw is now that if WooCommerce gets disabled, then the edit users privilege of that shop manager still persists. But the filter basically is not triggered anymore, right? The filter of checking, are you trying to edit an admin, that's not triggered anymore. And an attacking shop manager cannot actually disable the WooCommerce plugin itself, right? That would be automatically a flaw itself. But if we find a nice file delete vulnerability, we can delete the WooCommerce plugin. And once we delete the WooCommerce plugin, then the filter is not triggered anymore, and then we can delete the WooCommerce. We first delete the WooCommerce file, the filter is not triggered anymore, and then we are allowed to edit the administrator, and we have this privilege escalation. So the code here is nothing too fancy as well. There is some request parameter taken handle. There's some characters stripped, and it's passed to log handler, to the remove method, and then it's ending up here in the file path, which is then unlinked. So unlinked deletes the file, right? And this is typically something you automate, or you can automate with static analysis, right? Finding out something security sensitive and where does that come from. Does that actually stem from user input, and then you flag a vulnerability report. Okay, a little video for that. So we are a shop manager, we are logged in here. We cannot edit the admin, right? There's no edit flag here. But we can, again, use the log controller in WooCommerce, and we can delete the log file, which we pointed not to the log file, but pointed to the WooCommerce plugin. And now that the WooCommerce plugin was deleted, we can actually update the administrator's password. Then we administrate again, we can install our own WordPress plugin, and then we have this code execution again, right? Because WordPress plugins is PHP code, and PHP code can execute arbitrary system commands for us. Okay, next bug. So that was quite easy and nothing too new, right? I mean, file delete vulnerabilities exist. They just happened lately for us that we could use them in different ways to escalate privileges. Now we come to a new type of PHP exploitation technique, and this one was released at the Black Hat conference this year in August. So it's not that new, but in August new. And it's actually known since 1 year earlier, so we knew of it before as well, but it was released at least in August. And the credits go to Sam Thomas from Sekama, so he detected this bug. This exploitation techniques, and it's one of my favorites for today because it's pretty neat. I'm assuming that you guys have used PHP stream wrappers already when looking at file inclusions in the file inclusion session. Did you guys? Yes. Okay, so just to come back to them, typically you use PHP stream wrappers as an attacker to work on some data, right? So you have those neat PHP filters, those stream wrappers, and you can inject them into file operations, such as an include statement, right? If you have a traditional file inclusion vulnerability, and you can control the complete file name, so there's nothing prefixed at the beginning, then you can inject one of those stream wrappers and work with them neatly to exploit this file inclusion, right? So you can, for example, if you don't want that the index PHP file that you include is actually executed, but the content is leaked, then you use a PHP filter and convert the content to base64 encoding first, and then you get the content of the PHP file, right? Or if you want to inject arbitrary PHP code, you could pass that in base64 itself using the data stream wrapper, right? And then you have your your base64 encoded PHP payload being decoded and executed. And what Sam Thomas did now is to look at other stream wrappers, right? So he looked at other stream wrappers and thought, okay, what can you do with them? And he stumbled across the Phar stream wrapper. And the Phar stream wrapper belongs to Phar files in PHP. So those are PHP archives files. And well, I have never seen them in production, so I'm not a PHP developer itself, so maybe there is some good reason to do that. So what you can do is, it's similar to jar files in Java, right? You can wrap all your files into one archive file, all your PHP application into a single file, basically. I don't know really why you want to do that at the moment. Maybe because when you use Composer and install those packages, maybe that makes sense. Now the interesting thing with Phar files is that they store serialized data. I just asked before, so you guys haven't dealt with object injection before, is that correct? Okay, I'm going to explain a bit regarding to that. So when something is stored in a serialized form, that should raise some awareness for you as an attacker. Serialized form is always very interesting, not only in PHP, also in other languages. Let's first have a look how we would build a payload, and then we look what we can do with serialized data. So what we do here is we create a new Phar file, and in this Phar file, we add some file, right? So this is like kind of our PHP archive file. We add some random file to it, because it has to have at least one file. We add some stub, not that important what it is, but we need to add it. And then we set the metadata of this Phar file. And the metadata can contain objects. And since PHP cannot actually store objects itself into a string, right, it needs to process that into something unified, into something readable. And that is the serialized format. Who has heard of the serialized format before? Okay, not too many. Okay. So I think here we have a little example. I hope that's readable. So this is how it looks like. So if we add, so we invoke, we have any class, right? So we can choose the name, an arbitrary name of a class. And we invoke a new object of this class. And then we assign some data to this object and store this object as metadata. What happens now is if we open our Phar file with an hex editor just to look what's inside, we will see our stub, we will see the other file, but mainly also we see the metadata that we stored here. And the metadata is the serialized representation of our object. And that is just some unified string format to represent an object in a string. If you look carefully, you could reconstruct it just by reading it. It's saying it's an object with, and the name of the object of its class is 8 characters, so it's any class, and then it has one property, and this property is a string, and this is 4 characters long, and this is data. This is how the serialized string format looks like in PHP. And now the interesting thing is, if we use this, if we use the Phar wrapper on our now crafted Phar archive, then this serialized string format is deserialized. And deserialization means PHP, once it's using this Phar wrapper on our test Phar file, it automatically deserializes this serialized string. And that means it's invoking an object of any class again, and this object now has the property data with the string rips assigned to it. So we kind of have an, well, object injection, it's called. So we can inject arbitrary objects. We cannot inject arbitrary PHP code, right? So we cannot control the PHP code. We cannot write PHP code in there that's executed. But we control the object, its name, and its properties. And that's highly interesting because if you find some code in the application that you are attacking, and it looks like this, for example, this is the file class, and there is a destructor, and the destructor deletes a file, and the file name is stored in the data property, then we can change this serialized format here, right? That was data that we chose to put into this Phar archive. So we could say, let's not have an object of any class, let's have an object of type file, and into data we don't put rips, in data we put // wp config file, for example, and then this file will be deleted. Because once the Phar operation, the Phar wrapper is opening this Phar archive file, it will automatically look, is there metadata? It will automatically deserialize metadata, and that means it invokes this object, so the object is created of type file, or of the class file, and then the destructor is automatically called. In PHP, right, you have constructors, you have destructors. If you create an object, the constructor is called. If you destroy an object, and all objects are automatically destroyed at the end of the application lifecycle, then the destructor is automatically invoked, and this one will then unlink whatever is written in the data property, and that's in our control as well, so we can delete arbitrary files. I hope there was, in a 5 minutes wrap-up, object injection, kind of understandable. Okay, so this is object injection. This is Phar deserialization that leads to an object injection. Now we just have some tiny other challenges left, and that is, first of all, this vulnerability looks lame, right? So you say, okay, if I have a file inclusion vulnerability, why the hell would I use a Phar deserialization? I could just read arbitrary files or execute PHP code, right? That's why is that interesting? And second of all, you would say, okay, who's using Phar files, right? So how can I use Phar files if there's just an avatar upload, a JPEG file upload, right? Now the point is, the valid application that you're attacking doesn't need to use Phar files. You as an attacker create this Phar file, and you as an attacker can upload the Phar file to the server even as a JPEG file. So there are polyglot files that are at the same time a valid JPEG file and also a valid Phar file. And you can bypass any restriction there saying I only allow to upload a JPEG file, and you still get your Phar file on the server. And then you can point here with Phar // and traverse to your uploaded Phar file that's somewhere on the server, right? So that would work, as long as you have a file upload of some format at the application. And now the last challenge is, or the last question you might have is, okay, an include with user input, that's already a vulnerability in itself, but the whole point of that is that works with any single file operation in PHP. So not only with include or file get contents and file put contents, or with the file delete that we saw previously, so we can also have Phar deserialization in the previous bugs I demonstrated. But there are so many other file operations in PHP that automatically trigger Phar deserialization. And most interestingly, there are file operations in PHP that don't have any security sensitivity before that was released in August. So for example, file exist is now a very popular a very popular entry point for attackers, while before, if you would audit PHP code, you would see file exist doesn't do anything. It just checks if there's a file available or not, right? It could be like an information leakage, but it doesn't really do anything. It doesn't open files or delete files or write into files. It just checks if the file is there. But if you can control the input to file exists, and this is for that reason not much sanitized, right? Because it's not there's no awareness for that. Then you can inject your Phar handler in there and point it to a Phar file, and file exists before even checking does the file exist and doing its job. It's deserializing this metadata in your uploaded Phar file. Okay, may sound complex, and who's actually doing that? Well, here's an example. We found many Phar deserializations in the past. One of them was in PHP VB3, so one of the most popular forum softwares on the web, and it leads to a nice RCE again. So here we have exactly the example. We have a file exist checking a path, and this path can be controlled by an attacker. It's an authenticated flaw, so we would need to combine it again with other vulnerabilities. But an authenticated administrator or user of PHP VB3 cannot execute arbitrary system commands, right? That's nothing that you want to give an administrator of your forum of your bulletin board. You don't want to give him that permission to execute arbitrary commands. But what the administrator can do is he can change the file path to an image editor library. And this image editor library is then checked here in the code. If you change it, does that path actually exist, right? There's a file exist call on that path. And that's exactly the entry point here that we use as an attacker to trigger a Phar deserialization. So here's the step-by-step guide that you would do. So you would inject a serialized object with your gadget chain, meaning what we saw previously, we would find some PHP code in PHP VB3 that has an interesting destructor, right? Remember the one function we saw here. If we find that code in PHP VB3, and there was some similar code allowing us in the end to execute arbitrary PHP code, then we would create a serialized form of this PHP code. That would look like object, right, with 4 letters of type file, and in the data property, please put .. to delete something, or my PHP code in case that would be like an eval or an exec call. And this serialized string we would put into our Phar file as metadata, right? We saw that before how to build that. So we now have our evil Phar file. Now the upload restriction in PHP v3 was quite easy. You could upload only JPEGs or PDF files, but it's only checked based on the extension. So next step is we simply rename our Phar file to phar.jpg. Doesn't matter what the content is. It's now a valid JPEG file to be posted as an attachment if we add a comment or a new entry to the PHP VB3 board. If we want to upload this file now, it requires 2 more tricks, because first of all, it's stored temporarily at this destination, and there's some MD5 hash involved that is using some true random secret, which we cannot brute force. So we would need to extract that secret first to actually predict our file name, because later on we want to access that, right? And we could read out that secret from the database, basically. So we could use, as an authenticator user, we could dump the database, like a backup file, and then extract the secret, and then we would have that secret, and we could predict this file name, this MD5 hash of this file. And now the second trick involved was if we upload this file, then it would be only stored there temporarily, and once the upload is completed, it would be removed again. So the trick was to trick PHP VB3 into leaving that file for a little while more. And what we could do is PHP VB3 allowed to upload chunked uploads, and the chunked upload means I upload my big file in multiple chunks, right? So I upload my first part of the file, my second part of the file, and I actually never upload the third part of the file. I just tell PHP v3 it's a chunk of 3 files, of 3 parts, but I only upload the first and second, or only the first, and never continue uploading, so the file would stay there. And using those tricks then would allow me that I have an uploaded file that is persisting for a while, right? I could predict the random name. And then I can exploit the Phar deserialization. I can then inject my Phar wrapper pointed to my uploaded PHP v3 files. I know the hash finally, and then it would trigger automatically the Phar deserialization. And in the end, it would turn into a code execution. Okay, sounds a bit complex. Here's a little video which demonstrates that nicely. So for this case, we log in as administrator. Again, as an administrator, usually I cannot execute own PHP code, so I cannot root the server or execute system commands here. And we modify the DOM and we use some JavaScript that does all the work for us. So in the background, our JavaScript payload uploads a Phar file. It's uploaded it successfully. It dumps a database to get this salt, where we generate this random, where we can predict the random name of the file. Then we change this to the Phar deserialization. And what our payload in the end does is it writes a shell.php file into the web directory, so we can access it and, for example, execute PHP info. So we have our command execution on the server again. Okay, last example. I hope your heads allow me to present another one. That's the last one. Then we are done with all this stuff. So the last one is also one of my favorites. It's a bit older. It's from 2017, but I like this one a lot. It's an object instantiation, and it uses some nice little chaining to get, in the end, the command execution in Shopware, a popular e-commerce software again. Okay, let's have a look at the code. So the Shopware backend takes some parameter. I believe it's Symfony framework. I don't recall what it was. And it takes the parameter that is in the control of an attacker named sort and puts that into the unserialized method here. And in this case, it has nothing to do with serialization. It looks like it's an unserialized, but the method unserialized here is actually defined in Shopware. And what it does is it's looping over this serialized. So this is coming from our parameter, right? It's in the control of the attacker. And it's expected to be an array. And the code here loops over this array. And the key of the array is put into a reflection class. And the value is put into a new instant args. And those two are PHP built-in functionality that allows you to create objects of arbitrary types. So that sounds kind of familiar, but it's kind of like a reflection injection, right? I can control the name of an object that is created via reflection. So I can create any object that is defined in the code of Shopware here, and even control the arguments to its constructor. And now what we did is we looked through the Shopware code, but we didn't find anything interesting. Now the problem is with constructors, they don't do anything interesting, right? A constructor typically assigns data to properties taken from the arguments in a constructor, assigns to properties, but it doesn't typically do any security sensitive stuff. And we just learned also that destructor is invoked in some other magic methods, but the destructor, if it does something security sensitive, then it's operating on the properties. But we don't control the properties of an object, right? We only control the arguments of a constructor. There was nothing in the Shopware code that actually led to something security sensitive. Now the final idea was, okay, we are not limited to the classes that are available in the Shopware code. We can also use classes that are preloaded by PHP. So we can use PHP built-in classes. And that is, for example, simple XML element. That's a built-in class of PHP. And it has a very nice constructor because the constructor allows us to invoke the XML parser. So we can inject into the first argument XML data, and PHP will then parse our XML, or parse our data that we pass there as XML. And even more, we can specify in the third parameter, please take the first argument as an URL and fetch the XML file that you're going to parse. That's even more handy for us as an attacker. So we would set the third parameter to true, and then say, simple XML element, please load this XML data here. And this is the XML data that we would load. I don't know if in the HackPra sessions there was some XML injection stuff covered, or XXE. Then you guys have? Okay. Then you guys have seen maybe similar stuff, or maybe that stuff already. What we can do now is we can inject our own XML. So, right, we would say, please load this XML file and parse it as XML. And this is our XML file. It's on our domain. And now it would load this XML. And what you can do in XML is you can have an external entity injection. And that means you can specify entities and entities can also come from the file system. So for example, we could say, please load the entity etc Ph.D, and it would be embedded into this XML file. The problem is the output of this XML file, we cannot see that as an attacker because the constructor is not automatically flushing the output to the front end, right? We don't see what's happening in the XML file itself. So we use a little trick here and we say, please load as the system entity, not the etc Ph.D file directly. Please load this DTD file. And in this DTD file, again on our server, we would inject two other entities. The first entity is, please load the etc Ph.D file, and base64 encoded for us. And the second step is, please use this entity and perform another request to fetch some more data. We're not interested in what is actually fetched there. We are interested in that request being made, right? We put, because the content, the base64 encoded content of etc Ph.D is now stored in data, and data is put into the URL where more data is fetched from. And that means if we look in our access log as an attacker, we can see nicely, okay, the XXE file was fetched, then the DTD file was fetched as a second request, and the third request now being made is actually the base64 encoded content of etc Ph.D. So all we would need to do as an attacker, we check our access log, base64 decode etc Ph.D again, or the content of it, and then we have this as a side channel, this information leakage. And that was a very nice chain to actually retrieve some files. And then later on, so it was found in 2017, later on we thought, okay, how can we make this even cooler, because now we have the Phar deserialization. So we remember any file operation performs Phar deserialization. So we could even inject here our Phar deserialization at that point. And that would give us actually the opportunity to not only leak files, but to execute system commands again if we find some nice object injection chains. So to summarize this one, the chain would look like the following. We would first need a cross-site scripting vulnerability we had in the first session of HackPra. So we can take over the session of some user of Shopware which has access to the backend. With the XSS vulnerability, we would trigger, with a JavaScript payload, the PHP object instantiation. That was the one where we could inject our simple XML element, right? Invoke the constructor. In simple XML element, we could inject arbitrary XML data. The XML data that is passed then exploits the external entity injection flaw. Well, it's not a flaw, it's like a technique, right? Loading the other DTD file. The DTD file would trigger the Phar deserialization. Right? The Phar deserialization would have an object injection. We can inject arbitrary objects through an uploaded Phar file. The object injection itself would trigger a gadget chain. That's something we didn't cover today. But in the end, as you saw previously, the object injection can lead to a remote command execution if you point it to a destructor with something security sensitive. And it's a bit over the top, right? I mean, there would be simpler cases. That was just for the beauty of it, having it nice and complex. And that was the last bug. Okay. So what's the summary of all of that? Well, command executions are still everywhere. It's still fun, right? Go out and look for them, audit code after the HackPra sessions. We looked at some techniques you can use, like using file deletes vulnerabilities to remove some code, to change a bit the code flow, Phar deserialization as a bug type, maybe that's new, and object instantiation, something else, and object injection, also something to keep in mind when looking for code, for bugs in code. And other than that, enjoy the HackPra. I think it's very cool. It's you learn all those important things. One of the few lectures I find where you learn important stuff that you will really use later on. So enjoy that you have that at university. I think it's very cool. Also, if you want to learn a bit more about web security, we have at the moment a web security calendar. It's a PHP security calendar. We release a new security bug once a day in the most popular WordPress plugins like WooCommerce, Jetpack, all-in-one SEO, contact forms, and all those. So go to ripsack.com and maybe use the calendar and open your daily little gift. You can also, sometimes we have internal talks at Ripstack, so if you want to reach out to us and learn more about web security, feel free to do so. And I always recommend, probably it was mentioned thousands of times in the HackPra, but go to the flag swingers, learn with them, play with them, capture the flag contest. That's where I learned all my stuff in the beginning. I can always recommend that to take that for education. Okay, then thanks guys.